In Android, the file system works the same way that the file system works in Java, with some later enhancements that we're going to talk about in the second half of the session. The main thing that we're going to be doing here is reading and writing files. And I just want to, I expect people have done some of this with Java already. I'm going to hit some of the points on how the file system stuff in Java works. I'm not going to go in huge detail, but there's a few things I want to make sure we cover pretty well. So the first thing is the file class. And the idea of the file class is this is not actually representing a file itself. It's not something you can read from. It's not something you can write from. This is what's known as an abstract file name. And the idea here is that we can use this on any platform that Java would run on, or Kotlin for that matter, to be able to represent a file name on the file system. So it'll work on Windows, it'll work on Linux, it'll work on the Mac, it'll work on Android. All of those, it'll work just fine. From that file, we can use that as the name for a file that we're going to open up a stream on. And there's a couple things that we want to think about when we're doing the actual read and the write from that file. We have streams, which will be output and input. And we have writers and readers. It's really hard to write on this tablet screen. With the writers and readers, we're doing text input and output. With streams, we're doing binary output. And the main difference here is what type of character encoding we're going through. And when you use a stream, it's just strict binary. You're reading bytes off of the file system. And these are always in little endian order. I'm sorry, it's actually big endian. But it's fixed across all the platforms that are using this. That way, no matter what you're doing in Java, you always look at it from a big endian point of view. And just as a little note on the term big endian versus little endian, these terms actually came from Gulliver's Travels. And in the book, they had two countries who were at war with each other over which end of an egg you start eating first. Do you start eating it at the big end of the egg or starting at the little end of the egg? And it was a completely pointless war. And there's an author who wrote a paper about computer byte ordering, because there were two very conflicting standards on that, whether you start with the most significant byte of a number or the least significant byte of a number when you're reading it in from memory or writing it out to memory. And he compared it. He says it's as pointless as the big enders versus the little enders. And so he coined the term big endian for most significant byte first and little endian for least significant byte first. So, but whenever you're dealing with the I/O in Java for binary, it's always going to be big endian as far as your application is concerned. On the text side, it's going to use a character encoding that you specify. And normally you're going to want to use UTF-8 there, which is a Unicode standard. There are platform-specific standards that you can use. So depending on what you're reading from the file system, if you're reading something that a specific editor on Windows wrote, you might want to use a character set that's useful on Windows if that's how the file was encoded. But most of the time, you're really going to want to use UTF-8. And that's how any type of strings are represented inside Java in memory, is using UTF-8. So for readers and writers, when you take your input stream and your output stream becomes a reader, your output stream becomes a writer. You're applying an encoding in between so that as the data is read from the actual stream that you're reading, it gets converted into characters. So if you're trying to write things out, we can write that out using a character encoding. If you're trying to read it in, we can read in the bytes and convert it into characters automatically. So you don't have to worry about those translations. One of the things you can do with the file I/O system in Java is to use filters. And the easiest way to think of a filter is strictly thinking of a coffee machine. So if we have a coffee pot sitting down here, the coffee pot is where we're going to be writing some information to. We often call that a sink. That's the final destination. Now that could be a file. It could be a network. It could be an array. Whether it's an array of bytes or an array of characters. That's the final destination we're going to write things to. So if we directly open that up and start pouring in some bytes into it or some characters into it, we're not doing any type of translation on it. We're just spitting that information out. And we're spitting it out in the same size chunks that we send down through here. So if we send in a string that says hello, we're actually going to write those 5 characters in one chunk. If we have a ton of characters to write out and we only write them in 5 character chunks at a time, that's going to be really inefficient. If you're writing to a file in a file system, they tend to have a term, what the term for is, I'm going to call it chunk. They write out in chunks to the file system. So instead of trying to write out just a couple bytes at a time and having to reposition the read-write head on the disk, it's going to want to write out a much larger chunk of data at once. So what we'd like to do is add something in the middle here that allows us to buffer our information. So as the data gets poured into the buffer starts filling up. And then once it's filled, we can dump a larger chunk at once to the file system. That makes our file I/O much, much more efficient. But it's not something that automatically happens. It's something that you have to add into the scheme to let this file I/O stream know, I want to hold on to some data and blast it out in chunks to the file system. Similarly, if we had a vacuum here where we're sucking stuff out, we could use a buffer to pull in a large chunk. And then up here, if we only ask for 5 characters, we can grab it out of the buffer. When we ask for the next 5 characters, they're already in that buffer. So we're taking advantage of this system to make things a lot more efficient. Back in the late 90s, when I was flying around teaching, I was in Atlanta. And after I was talking about file I/O, somebody asked me at the end of the class, they said they were having some network I/O they were doing that was taking an incredibly long amount of time. And the first thing I asked them is, did you put a buffer in there? And they're like, what's that? And so I talked about the buffers with them and described what they need to do. And they came back the next day. They said, you just changed the performance of my application from somewhere along 40 minutes to about 2 minutes for the information they were sending. Because what they were doing is they were basically sending a byte at a time as an entire packet across the network. And they had to send a lot of data. And so they ended up wasting all this space in a possible packet going across TCP/IP. And by buffering it, that can set it up so it can send the maximal amount of information per packet across the network at once, which has a huge impact on performance. So things like that are really well worth thinking about here. We can also put other types of buffers in, or other types of filters in here. So we might have a filter here that gives us support for the println function. So instead of just writing out a character at a time and having to explicitly write out new line characters, you would have a println function that takes whatever you pass in, calls toString on it, and then automatically appends on that new line character. And that actually makes your application a lot more performant that way. It can also take advantage of whatever the encoding is for the platform you're on. So if you had you're doing something on Windows versus on Linux, it could also make the difference on automatically using a carriage return line feed versus just a line feed, or on the Mac using just the carriage return. We can hide some of that details behind the scenes by using some smart filters in there. And you can also put your own filters in there. We'll see a filter that we're going to write that's going to uppercase everything going through. Whenever you have something that does some kind of buffering in it, so some of your filters are going to do buffering. Some are explicitly a buffered writer, for example, where his whole purpose is just a buffer. Other ones might be doing some buffering as it's prepping data to go through. So maybe if we had a zip stream, the zip stream, let's say 2S, but if we had a zip stream there, this guy is going to be collecting data to compress before he sends it down. So some of the data may be buffered inside this thing before he actually writes it out to the file that we're going to write things out to down here. And when you're done, you want to make sure that any residual stuff laying around inside here gets flushed out. So you can explicitly call flush to dump that out. Flush is automatically called when you close something, though. So, but it's real important to understand, you want to make sure that you flush if you're not closing, and if you're at a point where you're saying, hey, I want to keep the connection to the network open, and maybe I want to make sure I send all the data across so the other side can respond. That's a case where you're going to want to explicitly flush to send that data across there. When you're really done, you're going to close that connection. And it's really important to do your close. Close is something that a lot of times you'd see people write code that looks kind of like this, where you'd have a try, you'd open your file reader, actually it'd say file writer. You would write stuff to it, and then you'd close it, and then you'd have catch with your exception and do something like that. So logically, it'd have the open, write, and close inside the try. And this is just plain wrong. The problem that we have here is that if anything goes wrong during those writes, the close will get skipped. And it's real important to do a close because he cleans up, whoops, the file handles. And there's a limited number of file handles that are available on whatever platform you happen to be running. And if you don't close those and your application keeps running, especially if you're opening and closing files like crazy, you're going to end up eventually using those all up, and you're holding on to ones that you're no longer using. So it's real important to close. And because of this, I used to talk about how you can set up try catch to take it to keep track of what you've opened and what you need to close, and then make sure you close things inside of finally. So you'd basically have a open, write, finally, close. Kind of like that. It's a lot more detailed than that, but the basic structure is you always want your closes and a finally. And because this pattern was so common, in Java, they decided to implement something they call try with resources. And that looks kind of like this. And what we're doing here is right after the try, we put the actual file opening and a variable to hold on to that inside those parentheses. And what that would do in Java is say, if the file that I'm opening implements auto closable, which just has a close function on it, that's an interface. If that implements auto closable, then the try will automatically do the finally with a close on it. And if you had multiple files listed inside, or multiple streams being opened inside here, it would do that for all of the streams that are listed inside there. And that was incredibly useful because it made it virtually impossible to forget to do your close. And you didn't have to worry about, do I put the close inside the try versus do I put it inside the finally? So in Kotlin, it's a little different than that. We have, let's write as an output stream. Say writer. We have a use function. And what the use function does is takes this lambda that's actually going to do your writing. And inside the use, he is going to close this guy once we're done running that lambda. And he makes sure that the lambda happens inside the try part of the try catch. And in the finally, he does that actual close for you. The equivalent of try resources in Java is use in Kotlin. And you're going to want to make sure that whenever you're doing file I/O, you always use that use. You don't want to just have a stream of things that says open writer, write, close. Use that use. It'll actually make your life so much cleaner. And you're going to be make sure that things are actually going to work correctly. And let's talk about the different kinds of file I/O, different types of I/O you can do inside Android. Now, to start with, it really depends on where you want to write your files. And there's a bunch of different locations. The main locations you have are internal storage, which is hidden from any type of user. The user can't get there, and external storage. External storage is a little bit of a misnomer at times because most devices don't have an actual SD card that you can plug into them. Originally, the idea was that internal storage was basically kind of like an extension of memory, except it persists over time. And an SD card that you can plug in is your external storage. Well, after a little while, programmers started yelling, saying, hey, how do I know when there's external storage or not? And so what they did on Android is they set it up so that every device, I should say pretty much every device, has a virtual external storage built into it. So all of the main storage that's on the device, it's broken up into internal storage, which other apps can't see and users can't see, and a virtual external storage drive. If the device has a physical SD card slot, then it can have a second external storage on this. You could have multiple external storages. And if maybe you plug in a USB drive, that's yet another external storage that goes in there. Just a little note on USB drives. If you want to use a USB drive with any of these types of tablets or phones, you need to get a special one called a USB on-the-go drive, or you need an on-the-go adapter. And those actually are called OTG adapters. And what that'll do is set it up so that it can communicate with the device. So the mobile device, whether it's a phone or a tablet, knows that this external drive is being used as an external drive as opposed to just a random USB thing being plugged in. I've got several of them that actually have two ends to them. One end is a USB-C end, the other end is a USB-A. And this is so that you can plug it into your phone or device, copy some data over, take it out, put it into a PC, copy the data onto the PC that way if you wanted to. Or, you could have your music sitting on this so that you can plug it in, but usually people end up copying their data directly to it. One little note, if you use a USB on-the-go drive, make sure you safely unmount it. There's usually when you pull down bring this guy over here for a second. If we pull down the notification shade here, there'll be a little thing here that says there's a USB drive mounted and have an option here to unmount it. Make sure you unmount it or you may lose some data. Very important to do that. And the same usually goes on Windows machines as well. You want to make sure that you unmount it safely. Usually the Windows devices are now set, so that's the default, that they automatically are safe to pop out. But you should really check that to make sure. And if you don't have it set to actually be automatically unmountable, you have to explicitly do the unmount. So we have our internal storage and external storage. And on internal storage, the only thing the application can write are files that are private to the application. On external storage, you can either write files that are private for the application or files that are public. So for example, if you wrote a camera application, in the camera application, you can store images in the public parts of the SD card that are common for people to look for images. And you're going to want to do that so it can share the information across different applications. So maybe a different app that's a gallery app could read those and display them. If, however, you had some files that were more private, maybe it's some sensitive user information or maybe a database, things like that, those all go into the internal storage or the external storage that are private to the application. Until fairly recently, the SD card was all public storage. You could write anywhere you wanted to on that. But now they're starting to lock it down and try to give you a sandbox to write into. That makes our life as a programmer a lot more difficult dealing with the external drive. We're going to see how some of that works a little bit later. But to start with, the main thing we want to look at is if you're talking about application-specific files, you have a files directory and a cache directory on both internal and external storage. And the cache directory is meant for temporary data. If you are gathering some information that you don't care if it goes away, but it's faster for you to get it once you've compiled it locally. that's a great place to put things. If you're writing a browser, for example, when you download some images, you may want to throw it in your cache directory. If the cache directory gets cleared, it shouldn't kill the application from running. So like if you're running a browser and you clear the cache directory for the browser, it'll just have to re-download things. It won't change any of your login information. It won't change any of your settings, that type of thing. You can have files in cache on either internal storage or external storage. The big thing to keep in mind here is anything that's app specific. First of all, other applications cannot access it unless you provide some very explicit way on how to expose that using a file provider. We're not going to get into that today, but there are some files that you can explicitly export for somebody else to get to. The most important thing, though, is that if the application is uninstalled, all of the files in these directories go poof. They're all deleted and uninstalled. And this is something that, with an application that I've been working on, up until recently, I had been using the SD card pretty liberally, where I had a custom directory at the root of the SD card to keep track of some reports and some images and things like that we generate. We don't want those to go away if the application is uninstalled. And also we had some map information so that they had offline map capability inside this application. If we put those inside of the application specific directories, that'll all get deleted. And we don't want to make the user have to re-download all the maps, just for uninstalling and reinstalling an application. Now, there's, in some cases, you have to make a call of, is the data going to be completely useless without this application? And in a case like that, you're probably going to want to keep it inside the application-specific directory so it doesn't just fill up their SD card. For the application that I'm doing, it was pretty common for users to uninstall the application and reinstall it, especially when we're doing different type of testing. So we didn't want to have them have to constantly recopy the maps over, because there was like 60 gigabytes of maps. The world is a big place. So that's the basic idea of application-specific files. Everything else is non-application specific. This page, by the way, is, if you look for data and file storage on the developer.android.com site, you'll see this page. So the next ones we have to divide into well, actually, I should come down here and first of all hit these two before I talk about the non-app specific. There are two more types of application-specific data. One are preferences. These are meant for small pieces of data that the user has set about how they want to run the application. Possibly a little piece of data to kind of say where they were in the application or what they were last looking at. You don't want to put much data in this at all. These could be things like the color scheme they want to use, some ranges that they want to display on a chart, their user login information, things like that could be stored in preferences. So just small pieces of data. Database is another piece of application-specific data. All of these are stored in internal storage. And the database is going to be something, obviously, that's a lot more data. The volume's a lot larger, and it's a lot more volatile. It's something that's likely to change a lot during the application. Or maybe if you have a read-only database, it's going to be read quite a bit. So if you have data that you have a structure to, you want to put that in a database. If it's just minimal data where you just want to keep a few of those, keep track of where you are, those are preferences. So those are the three types of application-specific files. So just general files, application preferences, and databases. Non-application-specific files either fall in the bucket of media or documents and other files. And there's two different APIs to get to those. Media files, and here we're talking images, audio, files, videos, things like that. These use the Media Store API. And this is actually something known as a content provider. I've put up that slide that's talked about the different components in Android, where we had activities, services, and broadcast receivers and content providers. Those are the four kind of main entry points into your application. A content provider gives you kind of a REST-like API to talk to another application, and he can expose data. So in this case, the Media Store API is one that's provided by Android itself. That's a content provider keeping track of all the media files. So any application can go and ask it questions like, hey, give me all the music so I can list it for the user so they can play it. Any other types of things fall into the documents and other files. This is where we talk about the storage access framework. And the storage access framework is going to let you access just random files and random spots on the SD card. But the big problem here, and something that gives me a lot of heartburn, is the user has to get involved. So when you say, hey, I want to go read a file from this location, you have to bring up a chooser for the user to pick it. You have no choice in that matter. Even if you know it's always going to be the same file name, they have to keep picking it. It gets a little bit easier once you can pick a route on the SD card where you want to work with. So maybe when the application starts, you say, hey, user, I've got some data I want to manage. I want to put it in a directory on the SD card. Please choose which directory that's going to be. So the user can choose that directory, and then our application is granted forever access to that so that we can keep reading and writing from that one directory. Unfortunately, those choosers don't let you custom the dialog title, which I have no idea why they've done it this way. And there's got to be some bugs reported on this, because normally if you have a chooser come up, you want it to say open, report file or save it to report file, so they know what they're choosing. All they get now is just a chooser. We'll see that a little bit later. So what you really kind of have to do is bring up another dialog in front saying, hey, user, you're going to be asked to choose a directory. This is the directory I'm going to store stuff in, blah, 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 blah. They hit OK, then they go to the chooser. So really not ideal. A lot of people have a lot of heartburn with the storage access framework, especially if they're writing applications that are doing file managers. So if you're writing a file manager application, which basically is, let me show you everything on the disk, you need to request some special permissions. And when you submit it to the Google Play Store, they're going to do an extra review on it to see what you're asking for and why you're doing that. File manager applications are the main target of that type of functionality, but maybe you come up with some application idea that really needs to have full unfettered access. That's one of those ones where you'd have to submit it, and you probably have to argue your case pretty hard. So these are the different types of application stuff there.